Radio! We are on page 28 of the HSE workbook. This is Engineering, Graphics and Design. Regardless of the workbook you are using, this is going to be an important video because we're talking about mechanical analyticals and we are going to address a couple of key parts or key features that you can expect. Now, this is of course for grade 11s, page 2.8 in the HSE workbook, and this is a step up from grade 10. So please, I believe this is our first one that we're doing together. Keep up with me. All right. First things first is just to get the lay of the land. They've given here for you a given figure shows the two orthographic views of two 3D models of a water pump flange. So it's one flange, two different views. Then there's a front view in 3D and a sectional view in 3D. And at the bottom here, there is your traditional title blocks. All right, with all its different parts. We'll talk through them as we go on. All right. Mechanical analytical is always going to be in first or third angle orthographic projection. Gaan dit altyd eerste hoeks of derde hoeks wees? Derde hoeks, papi. Okay? And so what we have here is, if you look at the indication here, the front view is where I see this water pump cover from the actual front, right? So there it is. That's our front view. That is then a right view. Mooi so. Regter aansig. This one is, however, a sectional right view. You can see that by the section lines. Okay, just to give you an overview, let's start by looking at the questions. The first question asks us to draw a right view of the water pump flange in the provided space, except for the C boreholes, all hidden details and center lines must be shown. Draw to scale 1 to 2. Okay, so they've given us here at number 1 an open space, and they're wanting us to draw a right view. Now, this is a sectional right view that's given. Hulle vra vir ons om 'n gewone regter aansig te teken, skaal 1 tot 2. Now, if you look at the title block, you'll see that this drawing that they've given us is already drawn to scale 1 to 2. There's very little measurements that we can use to draw this drawing. Okay? Well, actually, they've given us some heights. You can double check here. Let me just get that out. If I use my scale 1 to 2 ruler, alright, that says 160, and if you double check that, it is 160. So this drawing that they've given is already drawn to scale. So what I did to help me save some time is I literally lined my page up, and then I projected downward the different distances in the horizontal. Okay, so die horizontale mate het ek sommer afgeprojekteer. My vertical heights, I can use the measurements that's provided here. Now I'm going to rush a bit. You have to take your time to copy this yourself, okay? But I've just started it off so that we're able to finish this drawing in time. They then specify here at the bottom that all fillets and rounds are 3 millimeters. And you see there's quite a number of fillets and rounds on this. That is all 3 millimeters. Okay. So to help you save you some time, if you have a stencil like this, you can use the 3 millimeter. Well, it's going to be scale 1. Well, if it was a 3 millimeter radius, it would have been the diameter 6. But remember, we half scale, so I'm going to use a diameter 3 here. Okay. So let's quickly see if I can just rush through this one so that you actually see the memo for this. So I'm using that 3 millimeter to just get the different fillets and rounds drawn. It's too small to try and do with a compass. Alright, then there is an angled part. Just going to first do the construction line of that, and then add again that radius of 3. Oh, that's actually Okay, if you with me, you can already start drawing this, and then when you start answering the questions now, we'll run through that. All right. Right, sorry, this is actually hidden detail. I drew them in earlier because it's a right view, so you're going to have hidden detail here. Apologize for that. Same here. Always remember your center lines, and then we've got our oil hole here. And we're getting that from the section right view on top, and then down at the bottom, that's a M24. There's my center line. Yeah, my son. So yeah, so the measurements is divided by 2. Yeah, this is half scale. That's also hidden detail. Ja, my seun. Okay, so, right, I'll just refresh you. Okay, there's my external view of our flange, alright. The rounds here and the fillets, there's a fillet, they are all specified at the bottom as radius 3 millimeters. Okay, so I just drew this so that you have kind of a memo when you're drawing this yourself. You're going to get all of this hidden detail, of course, from the right view that's given. And you're going to just have to make sure you draw them hidden detail, not like I did the first round, and finish that right view of the flange. Okay, let's look at the other questions, because this is the only one that they're asking us to draw something. The rest of it, it's quite interesting. So then they ask us to print the title here of the water pump flange. I'm not going to do that fully for you, but you're basically going to use your ruler, give yourself some guidelines, and you are going to literally write in here water, and you're going to print it. Water pump flange. I'll just start with the water part. Water pump flange. All right. Then the next question asks that we insert the cutting planes to determine the sectional view on the appropriate view. Now they've actually gone already and they've answered that. There's the sectional right view. So just pay attention. This is the front view as is given. Okay. Hier is die vooraansig wat gegee is. Daai is 'n deursnit regteransig, né? Kyk hier, hulle het klaar vir jou die snyvlak ingesit. There's the cutting plane. There's the arrows and there's the AA. Already done that. Okay, now if I look at it from the front and I see that cutting plane, what part is removed? The part of the arrows. And so, and I'm going to look in the direction of the arrows, and what I see here, I'm drawing there. Do you see this front circle? That's that. See by me. Alright? that hole there, that one there. So if I look from the right hand side, what I'm drawing here. Okay. Now in the exam, they won't make this mistake to actually put in the cutting plane, but they asked us to put in the cutting plane. So you have to consider using what's given. There it tells you the front view. That is the sectional right view. Okay. On AA. So you would have drawn this in yourself. Make sure the arrows is on the right hand side because it's a section right view that you got to draw. Okay. Vooraansig en dan hierdie is dan ons deursnee regteraansig op AA. Dit wat aan die pylpunte se kant is, dit word as ek deursny weggevat en wat sien ek? Dit teken ek hier. Okay. Right, let's look at the next question. Name the projection system that's used, and of course it is third angle orthographic projection because it is mechanical. All right. Print an appropriate label for the given right view. So a label for this view would have been sectional right view on AA. Deursnee regteraansig op AA. Is jy by nie bly? Okay. Who made the drawing and when was it done? So if you look at the bottom here, it was drawn by J. Smith and you have the date there as well. Who checked the drawing and when was it done? Checked by Mr. Nkosi and the date is again clearly available for you. Ja. Wat was 5? Print an appropriate label for the given right view. Nee, ek het gesê, dit is daai deursnee regteraansig op AA. Name the system of projection is derde hoeks orthografiese. Okay. Alright, number 8. Who approved the drawing and when was that done? It was approved by Pinar. Can you see here? If you can read, you can achieve. All very straightforward. What CAD software was used? There it says TurboCAD Pro version 2. In what formats were the drawings saved? Let me zoom in a little bit for you here. So there's the TurboCAD reference and there's the file extensions .tcw and .dxf. Okay. Dis die formate waarin hierdie tekening gestoor word. Dis 'n TurboCAD program en dis die formate. Now they ask me, what does the abbreviation DXF stand for? That stands for Drawing Exchange Format. Dis dieselfde in Engels en Afrikaans. DXF staan vir Drawing Exchange Format. Write that down. That's the answer here. They've asked it in grade 12 as well. What does the format DXF stand for? Well, it stands for Drawing Exchange Format. Dit is net in Engels. Okay. Daar is die Afrikaans vir dit nie. Ja. In what formats were the drawings saved? Is TCW, DXF? There's the ticks.
What is it called? Drawing exchange
format. DXF is drawing exchange format. All right. State the type of material used to manufacture this part. So, if you look again at your title block, material, cast iron. Materiaal, gietijzer. As jy kan lees, kan jy presteer. All right. Number 13, what is the order number? Wat is die bestelnommer? Well, it's below that. Okay. Bestelnommer of die HKGK 69. Okay. Number 14, how many of these water pump flanges must be manufactured? Number required, 234. People, can it be easier than that? All right. Number 15, what scale has been used? Scale 1 to 2. Okay. Number 16, we'll state the file name and what it is used for. Okay, there's the file name, flange 0 to 1283. What is it used for? It's the name on which it's stored in the computer. Okay, dis die naam waar dit gestoor word op die rekenaar, of die manier hoe the name used to store it on the computer. In die ou dae het jy ou laseerkabinette gehad met papiere, nê? Nou is dit mos op 'n rekenaar wat jy dit stoor. Alright, we're now going to number 17, state the drawing number. There we have it below that. Okay. Number 18, include this drawing. How many times has this drawing been revised? Okay, let's see. How many times? Okay, there we look. What does it say here? This drawing supersedes drawing number 02122. What's this drawing number? 02123. What does that tell you? How many times? 3 times. Okay, so sometimes you have to go search for these answers. They're not just as straightforward as you could think. Okay. Number 19, what is the size of all fillets and rounds of the water pump flange? Wat is die grootte van alle filette en radiusse? 3 mm. Okay. Volgende ene, number 20, if a scale 1 to 5 were used, what would dimension A read? Let's zoom out here and get back to A for a moment. Alright, let's find A. There we have it. Okay. Oh, they try and catch you out here. Die mate nou lees 16. Onthou wat 'n skaal gebruik ons skaal? 1 tot 2. Nou vra hulle vir ons, if a scale of 1 to 5 were used, what would dimension A read? As 'n skaal van 1 tot 5 gebruik word, wat gaan nou daai maatskrywing daar lees? Onthou vir skaal 1 tot 2 lees dit 16. Wat gaan dit lees vir skaal 1 tot 5? Think about it. For scale 1 to 2, it reads 16. For scale 1 to 5, what's it going to read, people? No, still 16. The dimension never changes. The dimension remains 16. Whatever scale I draw a drawing, I can draw the scale 20 to 1. The measurement will still read 16. I can draw a scale 1 to 5. The measurement still reads 16. They're trying to catch you out. The dimension never changes. It's the actual size of the drawing that changes with scale. But the dimension is consistent. Hoor julle my? Alright. Good. What does feature B represent? So B is a fillet. Filet. It's a binneronding, maar filet is die regte woord. Fillet. Okay. Then they ask for C. So now I also have to go find these. There's C there. That is a keyway. Spygleef. C is a keyway. What is D here? It's a tapped hole. Getapte gat. So they've drilled the hole and then they tap it. They actually put a screw thread on the inside. So it could have probably been internal screw thread. That would have probably been okay. But it's also called a tapped hole. Getapte gat. Yes, young man.
What do you say for B? Sorry.
B is a fillet. Fillet. Okay. Then the next one asks E. That's a round. Ronding. Round. Ronding. Okay. Then we're on F. Let's see what's the question. Yeah.
Sorry, die onderstelle alle filette en radie is gelyk aan 3 mm.
Ja.
So, maar as 'n radie en 'n ronding sal.
Ja, dis die groot radius is die grootte van dit. Maar wat word daai genoem? Dit word genoem 'n ronding. As hy binne toe is dit 'n filet. Okay?
Nee, maar dit is want in die Engels jy sê dit fillet en round. So dan gebruik radie as die naam vir 'n ronding.
Die radius is 3 mm. Maar die eienskap as hy aan die binnekant is 'n filet. As hy aan die buitekant is 'n ronding. Okay. Next question. What is the angle of What is the angle between N and hole N and hole G? Where's N now? There's G, there's N. Okay. Alright, have a look at that. They're asking what is this angle? Alright, if I look at what is given here, it says 10 diameter drill, diameter 16 counterbore, 5 deep, 4 holes. I've got 1, 2, 3, 4. Okay, and they are going to be equally spaced. So it will be 90 degrees. 90 grade. 90 degrees. Okay. You can confirm that, of course, by measuring it. Alright, what is the angle of hole H? This is hole H, that's the angle. if it's not specified somewhere, you will have to go measure it. I think that's going to be 30 degrees. 30 graden. Okay. Given an alternative way of dimensioning the diameter 114 at F. Okay, that's this one here. I actually said that in one of my previous videos. So another alternative would have been pitch circle diameter 114. Remember why that is? It's this diameter here where I have 4 holes on. The diameter is 114. PCD, pitch circle diameter 114. Afrikaans is die alternatief SSD 114. Kan jy onthou waarvoor staan SSD? Steek sirkel diameter. SSD 114. Dis daardie sirkel en daar's 4 gate op. SSD 114. Okay? Alright, then they ask us to determine the diameter of hole H. Bepaal die diameter van gat H. Alright, so you're going to measure it here. If it's, I don't think there's anywhere else where I can find that except measuring. Alright, so you're going to use scale 1 to 2. And it is diameter 22. Diameter, the answer is diameter 22. Remember scale 1 to 2. Scale 1 to 2, this drawing is half the size. So if you took a scale 1 to 1 and you measure here 11, you have to times it by 2. But if you use scale 1 to 2 already, there's no conversion needed because it is already scale 1 to 2. Happy? Okay. Yes, my child. Diameter. So the answer must read here diameter 22. Right, calculate the following dimensions. Now they're asking us at J. There it is. Alright, it's this external diameter. So if I double check there, do you see it is in line with diameter 144. Okay, so the answer again is diameter 144. Ja, monsieur. Daai hoekie is hierdie een. Okay? Daai ene. 141. Okay, just double check. Alright. That one in line there, it is diameter 144. Then the next one, K. Let's find K. Okay, there it is. It's this distance here. Alright, so if I look at that, and I look at what is here on top, I'm going to try and calculate it. What do I have? I've got 17 plus 4 is 21, right? Now if I come down here, now I've got 5 here, so it's 5, 21 minus 5 leaves me with 16. K is 16, alright? Just double check. Oh, they are, sorry, no, they aren't in line. There, okay, that's 21. Okay, it's 17 plus 4, that's a 21. K is 21. Okay, just use your ruler. I didn't do that initially. So that 17 is in line with that outside. There's 17 plus 4 is 21, so K is 21. Right, then L. Where's L now? There it is. Alright, so it's this. Alright, it's the counter bore. If I look at the note here, the initial hole is diameter 10, then a counter bore of 16. So die initiële gat is diameter 10 en dan is daar 'n versinkte gat. Dis reg, versinkte gat wat diameter 16 is. So die buite diameter daar is 16, diameter 16. That's L. And then the last one is M. It's this screw thread here. And of course, let's just look here. There it is, M24. So it is a diameter 24. M24. Does that make sense? We did this internal screw threads yesterday again. Okay, so it's a diameter 24 is the answer for M. Okay, if 1 inch is 2.54 millimeters, what would dimension P read in inches? So let's just find P. There it is. Diameter. It reads now diameter 160. So let me just do that sum for you. It's currently reading diameter 160. Okay. Now they're saying if 1 inch is equal to 25.4. How many inches is 160? What do you have to do? You have to take 160 divided by, what's the answer? 6.3 or 6.4 inches. Okay? You see a little bit of mathematics coming in here? So you just have to read, then you can achieve. If 1 inch is 25.4, they're asking me what in inches will this diameter now read. So diameter 160, divide that by 25.4 gives me 6.3 inches. Alright, which view of the water pump flange is shown? View R. That's just a regular front view. View S is our full sectional right view. Vols deursnee, regteraansig. Hierdie kant is 'n vooraansig. Duidelik? Water size key will be used when assembling the water pump. Alright, there we go. There it is. The key is 4x4. Okay, 4x4. Watter grootte spy gaan gebruik word wanneer ons hierdie saamstel? Daar sê dit vir jou die spy se grootte. So baie van hierdie is net regtig waar mooi lees. Which company is going to manufacture? We've got it down here, Wilmer Industries. So people, what you have to take from this, I know it's a lengthy discussion, okay? But the mechanical analytical asks you to analyze that which is given and to use that information to answer the questions. Meeste van hierdie antwoorde kon jy kry as jy geweet het waarom te kyk. Okay, so dis 'n meganies analyties, die eerste een vir die jaar. Dit is so 'n bietjie moeiliker as natuurlik graad 10. Maar ek is seker jy gaan sommer baie goed doen. Alright. Thank you for watching. All the best answering this. Now it's your turn.